We're going to start today by graphing these three functions and kind of seeing what they have in common. We're going to create a table of values for them. So we have y equals 2 to the x, y equals 3 to the x, and y equals 4 to the x. So we'll start by creating a table of x, y values. And I'm going to use -2, -1, 0, 1, and 2. All right, so first we're going to plug in -2. So 2 to the -2 power. Now remember, the way we get rid of negative exponents is we move it down. So this is 1 over 2 squared, which is going to be 1/4. And then we have 2 to the -1. And again, to get rid of the negative exponent, we're going to move it down. 1 over 2 to the first power, which is 1/2. 2 to the 0 is 1. 2 to the first is 2. And 2 squared is 4. Now we're going to plot these points. So -2, 1/4, right here. -1, 1/2. 0, 1. 1, 2, and 2, 4. So you can see what's happening here is as you go to the right, it is going up. And as you go to the left, it's kind of leveling off like that. So if we go and find, where's domain and range? Scroll up here a little bit. Okay, so the domain is going to be all real numbers. We could plug in anything we want for x. And notice our range is going to be y is greater than 0. It's never actually going to touch 0, so it looks like we have an asymptote right there. It's just getting closer and closer to it. It's basically flattening out here, closer and closer, but never actually touching it. All right, let's try the next one. We're going to plug in to our xy table. We're going to do the same values, -2, -1, 0, 1, 2. So this time we have 3 to the -2. Again, to get rid of the negative exponent, that's 1 over 3 squared, which is 1/9. 3 to the -1 is going to be 1 over 3 to the first, which is 1/3. 3 to the 0 is 1. 3 to the first is 3. And 3 squared is 9. Sorry about those scribbles. It's very messy. All right, -2, 1/9. -1, 1/3, 0, 1, 1, 3, and then 2, 9. I can't fit on here. So you notice this looks a lot like the last graph. It's going up a little bit faster. It's a little steeper than the first one, but this is still approaching that same asymptote. So again, we have all real numbers, and our range is greater than 0. All right, let's do one more table of values. For y equals 4 to the x, same numbers. So we have 4 to the -2, which is going to be 1 over 4 squared, so 1/16. 4 to the -1 is going to be 1 over 4. 4 to the 0 is 1. And 4 to the first power is 4. 4 squared is 16. These are really hard to graph. -2, 1/16, that's, yeah, whatever. -1, 1/4. 1, 0. 1, 4. And then 2/16 I can't fit. And again, same graph. Notice it goes up even faster than the last one, and it flattens out faster as well. So all real numbers, and again, our range is y is greater than 0. So all three of these things that we've just graphed are called exponential growth functions. And so exponential growth functions happen when you have a constant base and the exponent is a variable. So notice they were all to the x power. That's an exponential function. If b is greater than 1, that's our base. If it's greater than 1, it's going to be exponential growth. Later on, we'll take a look at things where b is less than 1. And then this a, in all of our problems, a was 1. We'll see a little bit later. This is going to cause some transformations. But this is our basic formula for exponential growth. Y equals a times b to the x. Some key features of this, if we notice what these all have in common, the domain is always going to be all real numbers. Okay, you can plug in anything you want for x. The range, remember, was always greater than 0. That's because we had an asymptote at y equals 0. So on the left side, it was flattening out, and then on the right side, it was growing really fast. Notice all of the graphs up there had an intercept of 0, 1. And that's going to be really, really important in the next video when we do our transformations. Our asymptote is y equals 0. And then end behavior. As x approaches infinity, so this is our right hand end behavior. So on the right side of the graph, our y was going up towards infinity. As x approaches negative infinity, that's our left hand end behavior. Our y was flattening out and getting closer and closer to 0. But remember, it was not actually touching it. So what you need to know, this is a new parent function. You need to know that exponential growth graphs look like this. Okay, they're flattening out to the left, and then to the right, they're going up really, really fast. And like I said, this intercept, we're going to use that to do our transformations in the next video.